Alicia, and today I will be discussing Lab 4, Circuits and Capacitors. Lab was to predict behavior of circuits containing resistors in series and parallel, and to use multimeters to measure actual values of conventional current and potential differences in circuits, as well as to examine the behavior of ohmic resistors and capacitors. And states that the change in potential difference for a loop is always going to be equal to 0, as well as the node rule, which deals and states that all of the currents coming into a node has to also come out of it when a circuit is at steady state. Experiment where that the resistance 47 for the 47 ohm resistor was actually 48 ohms. The resistance for the 100 ohm 102 ohms. The resistance for the wire and the ammeter were both 0 ohms. And in the RC circuit, had a charging time of 8.31 seconds, a discharging time of 26.56 seconds, and the 20 ohm light bulb had a charging time of 25 seconds, while the discharging time was 52 seconds. Graphed my graph, I got an RC of 6 seconds, which was also equal to the computed value from the actual circuit. This experiment, I had to first measure the voltage across several different points, and the I got when I added them all together was equal to 0, which is expected due to the as the current being equal to 0.02 amperes, which is what I predicted. That which made sense because the voltage going out and the current going out is equal to the current coming into the battery. For the voltage at each point, and as you can see, it ends up being 0. Linear, for my logarithm graph, I got an RC by -1 online, so the only possible source of error was in rounding. In real life and used an actual ammeter, the a that would have affected the current. Then it would take even longer for the capacitor to reach full charge.